And if I have CO2 in my blood, I need that CO2 to dissolve in this fluid, cross here, and breathe out. Is everybody following me? This is what you need to know. I need the CO2 out. Why? Huh? What?
I just said the pH level of blood.
It's toxic. So I need to make sure that as my blood is circulating, comes here, that this CO2 can dissolve, get here, and breathe out. And then I need to make sure that O2 here, if needed, note my terminology, if needed, can dissolve and move to my bloodstream, to those red blood cells.
When would CO2 move in?
Well, now, I showed the CO2 here because that would be going out. We don't want CO2 moving in. But your alveoli is going to have both.
I thought you were saying if needed, CO2 could.
Oxygen. If needed, I need oxygen to be able to dissolve and come in. I need my CO2 to go this direction every time. Okay? But do you think that every oxygen molecule that comes in is needed? No. Why? Because ever since I can remember, everything's always about oxygen. I gotta breathe, give me my oxygen, give me oxygen. Go to the hospital, and they put that little thing up my nose. All right, it's oxygen. People have stuff in their homes. It's oxygen. Right? But now I'm telling you, does every single oxygen molecule that come in need to go? Mm-mm. Why?
I have a question. You say go in, or so like does the oxygen need to leave, or oxygen needs to stay? What are you trying
Well,
to
now,
say?
once oxygen comes across, hopefully it doesn't go back to the alveoli. Hopefully it stays on that red blood cell, on that iron molecule, the hemoglobin. So, if I have a red blood cell that makes a circuit around my body every minute, all right, and on that one red blood cell, I have 4 irons, each one that can attach an oxygen. So if all 4 have an oxygen, it is 100% saturated. Put the phone up. 100% saturated. Okay? As it makes the circuit around the body, it may only drop 1 oxygen off. It still has 3. So as it comes back to its circuit in the lungs, it only has to pick up 1 oxygen, which chances are, based on saturation, what is a normal saturation? Anybody ever had that thing put on their finger? The pulse ox? What is a normal saturation?
100.
100, that chances are you're going to hang 98, 99. Okay? 95, yeah, they'll take. You start dropping below 95, well, we got to be concerned. So roughly 95, 96% saturation. So that tells me not every single iron on the hemoglobin of every single red blood cell is got an oxygen. Plus, if the tissues are not active, oxygen doesn't need to be dropped off. So therefore, which of these two gases do you think is going to dissolve more easily in this fluid, the respiratory membrane, the water?
CO2.
CO2. Your breathing, almost everything about it, is based on the carbon dioxide. I know, right? Did you know that? Because why? What happens when carbon dioxide gets into the blood?
It changes the pressure.
Acidic.
Acidic. pH. The pH of the blood needs to be maintained at roughly 7.45. The body will do everything possible to keep it at 7.45. And that means affecting your respiration rate. So CO2 is going to dissolve more easily. So Henry states that based on this air-water interface, it is going to affect the pressures of my gases based on their ability to dissolve in water. So Henry's law, don't get me wrong, okay? Henry's law is, to me, the most important one. Respiratory therapists will argue that, okay? But that's because I'm not a respiratory therapist, okay? All the gas laws are important, but Henry tells me the physiology of what's happening, if that makes sense, okay? The other ones tell me something about the structure of this system. So, when a respiratory cycle occurs, meaning one inhale, one exhale, okay? Yes, we're going to have something that will start the respiration, something that will deal with, okay, does it need to be shallow, deeper, faster, quicker, whatever the case might be, and something that says, whoa, enough, let's start the cycle again. So, to start the respiration in the medulla, medullary, okay, in the medulla's respiratory centers, like I said, neurons constantly active, reverberating circuit, okay? The center will get stimulation from a receptor. What types of receptors were present? Chemo,
Central.
stretch, but we had the central and we had the peripheral for the chemoreceptors. The stretch receptors, irritant. So they receive some type of stimulation. And we can also affect our breathing, with emotion. Oh my goodness, are you kidding me? No way! I know I should be on the stage, right? Did you notice how the breathing was affected both times? Okay, so even though we have this control, it is affected. Okay, and in some cases, people do stuff to affect it, like doing yoga, biofeedback, that sort of thing. Okay, so it'll take all information and create an action potential. Does everybody remember that term? Okay, create an action potential that will go to my respiratory muscles, that diaphragm and those intercostals. Okay, then do I need, okay, do you guys remember dorsal, ventral, all that sort of stuff? Okay, so now it's like, okay, well, do I need to increase it, decrease it, make it faster, make it deeper, shallow, whatever the case might be. And then information has to go in, a lot of it, those stretch receptors, okay, because it's like, whoa, okay, they're only going to allow that to occur to a certain extent and say, whoops, got to stop, let's reverse this and go back to inspiration. Now, as we carry out inspiration and expiration, one of the things I mentioned, we can have resistance. A lot of times, resistance is based upon the bronchioles. For example, somebody that has asthma, do you know what happens to them when they're having an asthma attack?
The airways closed.
Now, their airways close and do what? It seems like they are. It seems like they are based on it. Now, their airway constricts. Have you ever stopped to think exactly what does that mean? Have you ever really thought? I mean, see, this is one of the things I just love about stuff out there. Okay, they'll be like, "Oh, this new asthma medication because your airways constrict." Okay, unless you've taken my class, chances are you could be thinking here. You could be thinking bronchi. No. It's at that area of the bronchiole, meaning we're getting to the very small tubing going to that alveoli. All right? And remember, we're getting to areas of elasticity and smooth muscle. And what that does, that smooth muscle that's found, will cause that bronchiole to constrict, meaning that that alveoli does not have flow. That is resistance. Does that make sense? So, people that tend to have, like, or be in, like, the active asthma attack, some of them have their inhalers. Okay, a lot of those have come a long ways in helping with the problem. What do you think it's affecting?
Bronchioles.
But what of the bronchioles?
Smooth muscles.
Our smooth muscle. Okay, make it relax. And then they may take medications on a regular basis to keep that under control. So they've come a long way in treating that. So diameter of the bronchioles usually has a huge influence on anything that could create resistance, movement of the air. The other one, pulmonary compliance. Compliance. How easy can my lungs and the thorax expand? What does that tell me? First of all, the ease with which my lungs. What does that refer to? What does that mean?